Welcome to the podcast series of Middle East and Africa Textile Journal.
Thank you. Yeah, it's great to be here.
So I want you to do something for a second. Wherever you are right now, just reach down and touch the fabric you are currently wearing.
Yeah, just really feel it.
Right. Rub it between your fingers. Pay attention to how it actually behaves. Like, is it incredibly soft, or does it have a bit of a crisp stiffness to it?
Exactly. Or when you pull on the hem, does it stretch and bounce back? Or does it sort of hold a rigid shape?
Yeah. And the thing is, when we think about what makes that specific shirt or those pants feel the way they do, we almost obsessively focus on the raw materials.
Right, the ingredients.
Exactly. We check the tags, we see 100% cotton or silk or, polyester blends, and we just think, well, that tells the whole story.
Which is so funny because it really doesn't.
Not at all. I mean, or maybe if we're a bit more mechanically minded, we think about the weaving process, right? Like those massive industrial looms crossing the threads back and forth.
So the construction phase.
Right. But here's the wild thing we are exploring today. That actual physical feel of that fabric under your fingertips, that sensory reality was likely decided at the very, very end of its creation.
In a stage most people don't even know exists.
Exactly. A stage that most of us never think about and certainly never see.
Yeah, I mean, we look at a garment and our brains register the yarn and the weave, but we are completely blind to the finish.
It's a huge blind spot.
It is. Historically, the broader public has just entirely ignored the finishing stage of textiles. People picture fields of cotton or spinning wheels or automated sewing machines.
Right, the classic factory imagery.
Yeah. Yet the finishing stage is the exact microscopic moment where a fabric's movement, its breathability, and its literal tactile touch are permanently shaped.
Because before that, it's not really something you'd want to wear, right?
No, not at all. Before finishing, a piece of woven cloth is basically just a raw, unstable grid of threads.
So we have this absolutely fascinating stack of sources for our deep dive today that kind of peels back the curtain on this exact blind spot.
It's a really great history.
It is. We are looking at a targeted historical overview that explores the evolution of textile machinery. And specifically, we're following the story of this Italian innovator named Fiorenzo Biancalani.
Right, a really pivotal figure.
Yeah. And our mission today is to figure out how this overlooked, seemingly mundane final step in manufacturing actually dictates the value, the performance, and even the environmental impact of literally everything we wear.
It connects to so many big issues.
It really does. And to get our heads around the basic concept, before we jump into the history, I was trying to map this onto something we all understand.
Okay, let's hear it.
Well, if making a piece of fabric is like baking a cake, right? The spinning of the yarn and the weaving of the threads, that is really just measuring out the flour, the sugar, and the eggs.
The raw prep.
Exactly. You just have raw ingredients sitting in a bowl. The finishing stage, though, that's the thermal baking process. It's the chemical reaction that happens in the oven.
I like that.
Right. It is the thing that transforms those raw ingredients into an actual cake rather than just leaving you with a bowl of wet batter.
Yeah, the chemistry of baking is actually the perfect parallel there because, you cannot simply eat a bowl of raw flour and eggs.
No, definitely not.
Right, no matter how high quality or expensive that flour is.
Yeah.
The heat of the oven alters the molecular structure of the ingredients to make them digestible and appealing.
It fundamentally changes them.
Exactly. And in the textile industry, you cannot wear raw, unfinished woven yarn. If you took cloth straight off a mechanical loom and tried to make a shirt out of it, it would be incredibly rough against the skin.
Like wearing burlap or something.
Yeah, worse in some cases. It wouldn't drape or conform to the body, and the second you washed it, it might just shrink unpredictably or completely warp out of shape.
Oh, wow.
Finishing is that essential transformation. But for a very long time, the industrial world just treated that critical process as an afterthought.
Just a chore.
Yeah, just a mere logistical hurdle.
So to understand why it was treated that way, we have to travel back a bit, right? To 1957, specifically to the city of Prato in Italy.
A huge year for this industry.
Absolutely. And to set the scene for you, 1957 Prato was not some sleepy artisanal village making, quaint little garments.
No, not at all.
It was a booming, highly aggressive European textile center. The post-war economy was just ramping up, populations were recovering, and factories were expanding at a blistering pace to meet this massive, rising global demand for consumer goods.
It was a total powerhouse.
Right, an absolute powerhouse of industrial production running day and night.
And with that scale of rapid post-war growth comes a very specific and honestly a highly rigid industrial mindset.
It's like output over everything.
Precisely. In 1957, textile finishing was viewed strictly as a technical end-of-line necessity. The loom created the fabric, and the finishing department just had to process it so it wouldn't fall apart. It was purely an industrial bottleneck, just an obstacle to clear before a factory could pack those heavy rolls of fabric onto a truck and ship them out to buyers.
Get it out the door as fast as possible.
Exactly.
And the machinery manufacturers of that era, they were catering entirely to that bottleneck mentality.
Okay,
right?
100%.
They looked at a finishing machine and evaluated it purely on mechanical metrics, like what is the maximum speed?
What is the daily output in meters?
Right. What is the maximum efficiency we can squeeze out of this motor? It was an environment just obsessed with volume and velocity.
Very loud, very fast.
And right in the middle of this loud, output-obsessed landscape, Fiorenzo Biancalani opens up a small workshop, Officina Meccanica Biancalani.
Yeah, a very modest, detail-oriented operation, trying to find its footing in a very brutal industrial landscape.
But wait, I have to push back on the premise here for a second.
Okay, go ahead.
If Prato was already this incredibly successful textile hub, right, pumping out massive volume and making serious profit in 1957, why would anyone look at that and say, we need to completely rethink this?
It's a fair question.
Right. From a business perspective, if the factories are humming and the fabric is selling as fast as you can weave it, why did Biancalani feel the need to invent anything new? Like, was the industry fundamentally flawed, or was he just a classic tinkerer looking for a problem to solve?
Well, volume is a trap, especially in a recovering economy.
A trap? How so?
On paper, sure, nothing was immediately broken. They were producing textiles and they were generating revenue. But Biancalani saw a massive looming blind spot that the volume-obsessed factory managers were totally missing.
Which was?
The industry was successfully manufacturing raw products at high speeds, but they were completely ignoring the sensory experience of the human being who ultimately had to wear the product.
Oh, wow. So they were just looking at spreadsheets and output quotas.
Exactly. Totally disconnected from the tactile reality of the clothing itself.
That makes sense.
The factory managers viewed the touch of a fabric, the softness, the natural movement, the way it falls over the shoulder, just as an accidental byproduct of making cloth.
Just whatever happened, happened.
Right. But Biancalani realized that those sensory elements could not be left to chance. They had to be deliberately engineered.
In the sources, there is this core philosophy that Biancalani develops, and it honestly sounds more like something a sculptor would say than an industrial machinist.
It really does.
His defining revelation was this, quote, "We are not just building machines, we are transforming fabrics."
That is the pivotal mindset shift right there.
It's beautiful. Like, fabric isn't just a commodity you output by the ton, it is an engineer experience.
And we really cannot overstate the profound economic impact of that single philosophical shift.
Tell me more about that.
Once you understand that fabric is an experience, finishing suddenly stops being the end-of-the-line bottleneck and becomes the most powerful tool in the entire factory.
Okay, give me an example.
Sure, consider a very real scenario from the modern supply chain. A factory produces thousands of yards of fabric. The fabric is spun from the exact same batch of raw cotton,
Okay.
and it is woven in the exact same pattern on the exact same mechanical looms.
So they are structurally identical twins at this stage.
Yes, down to the microscopic weave. But then they are sent down two different finishing lines.
Interesting.
Because of the finishing, they emerge as entirely different products.
Really? Entirely different.
Completely. The fabric finished with basic, aggressive, traditional methods remains completely average. It's destined for discount bins or cheap utility wear.
Right.
But the other fabric, treated with an engineered high-end finish, it develops a luxurious drape, a soft hand feel, and a premium luster.
Wow.
That second fabric becomes a highly sought-after product for boutique fashion labels. The finishing alone dictates the final value multiplier.
It's like taking the exact same harvest of green coffee beans.
Oh yeah, that's a good way to look at it.
Right. You have these identical raw agricultural products. The roasting process, which is basically the finishing, entirely dictates the final consumer experience.
Exact.
Depending on the thermal dynamics of how you roast those exact same beans, you either end up with a cheap, burnt-tasting cup of diner coffee or a premium artisanal espresso that people will gladly pay 5 times as much for.
Spot on. Because the roasting uses specific thermal dynamics to unlock the oils and alter the chemical structure of the bean.
Right.
The raw material merely sets the baseline potential, but the finish creates the character.
That's a great way to put it.
And for the textile industry in the late 1950s and 60s, this was a monumental paradigm shift. Biancalani effectively moved finishing from the bottom of the hierarchy to the very top.
Framing it as the ultimate value creator in the supply chain.
Exactly.
Yeah.
He challenged the industry to stop asking how fast a machine could run and start asking how much value that machine could add to the raw material passing through it.
But, having a beautiful philosophy about transforming fabric is great, but Biancalani still had to build a physical machine out of steel and gears to actually do it.
Right, the actual engineering.
Yeah. Our sources detail a massive technological leap that came directly out of this mindset, which is the birth of air-based technologies.
It's a huge breakthrough.
But I really need to understand the physics of this, because the sources mention that this air-based tech replaced what they call aggressive mechanical action.
Yes.
Before this invention, were we essentially just beating fabrics into submission to finish them?
Honestly, yes. Traditional finishing was incredibly harsh on a physical level.
Really?
Yeah. Imagine the tension a thread is under when it is being woven on an industrial loom. It is pulled completely taut.
Right, it has to be tight.
Exactly. So when it comes off the loom, it is incredibly stiff. To soften it, the old methods just relied on brute force.
How brute are we talking?
Factories used massive machines called calendars, and they featured thick, heavy metal rollers that literally crushed the fabric flat under immense pressure.
Ouch.
Or they used mechanical beaters that would repeatedly strike the cloth to physically break down the stiffness of the raw fibers.
Wait, literally hitting it. You are forcing the fabric to soften up by physically degrading it. That has to put immense stress on the structural integrity of the garment, right?
It absolutely does. It creates microabrasions and weakens the polymer chains within the yarn.
That sounds terrible for longevity.
It was. And that's why Biancalani's air-based technology changed the physics of the factory floor entirely. Instead of using aggressive physical force and heavy metal contact, they began using targeted high-velocity airflow.
Just air.
Just air. Air acts as a fluid medium. When you use air to move, tumble, and process the fabric, it creates a much more natural structural effect.
So it's almost like a wind tunnel for a skydiver.
That's a fun image.
Right. Instead of the fabric being dragged across a concrete floor or crushed between steel plates, it's suspended and tumbled weightlessly by aerodynamics.
Exactly. The kinetic energy of the high-velocity air does the work that the heavy metal rollers used to do.
Oh, wow.
The aerodynamic tumbling mechanically relaxes the yarn without any harsh abrasion.
Because there's no metal crushing it.
Right. Because the fabric isn't being pulled tight over metal, the individual fibers are allowed to naturally relax, swell, and bloom. It reduces the internal stress on the fibers while simultaneously enhancing the softness, the volume, and the natural drape of the material. It fundamentally alters the physical reaction at a microscopic level.
But wait, if the whole industry in Prato was obsessed with maximum speed and clearing that bottleneck, doesn't gently blowing air on fabrics and tumbling them around completely slow down the factory line?
You'd think so, initially.
Yeah. How do you convince a cutthroat factory manager to buy a machine that sounds like it takes twice as long to do the job?
Because a factory manager cares about the final margin.
The profit.
Exactly. While early air tumbling might have seemed counterintuitive to a volume mindset, the value multiplier we discussed earlier totally changed the math.
Right, the premium.
Yeah. If an air-finished fabric can be sold at a 40% premium because of its superior hand feel, the factory manager suddenly cares a lot less about running the machine at maximum speed and a lot more about achieving that premium grade.
Quality over sheer quantity suddenly makes more money.
Exactly. Furthermore, as the engineering evolved, these air-based machines scaled to incredible industrial speeds anyway.
Oh, they caught up.
They did. They achieved continuous flow, meaning the fabric was constantly moving through the aerodynamic chambers without ever needing to stop and be pressed.
So you get the best of both worlds.
Right. They matched the speed of the old brutalist methods, but delivered an infinitely superior product.
Reading through the technical evolution in the sources, you really get the sense that this specific innovation elevated the finishing stage from a harsh, loud industrial chore into something almost artistic.
Absolutely.
Like they were meticulously crafting the final touch using the invisible force of air.
It was a huge shift from brute force to refined engineering. And that refinement transitioned from being a luxury to an absolute necessity as the decades progressed.
Because the economy changed.
Fundamentally, the global economy entirely reorganized itself.
Right. And that brings us to the next big shift in our timeline, which is the era of global survival.
Survival era, yeah.
Fast forward into the 1980s, 90s, and 2000s, and the global competition in textiles just explodes. Massive production centers emerge in Asia and across the developing world.
The scale was unprecedented.
Truly, the global market is suddenly flooded with this massive production capacity. And European mills, like the ones in Prato, quickly realized they were facing an existential threat. They just could not survive by competing on price alone.
No, because if you compete purely on price in a globalized commodity market, it is a race to the bottom that you absolutely do not want to win.
Someone is always cheaper.
Exactly. Someone somewhere in the world with cheaper labor or subsidized raw materials is always going to be able to manufacture a basic yard of fabric for less money than you.
So, to avoid that race to the bottom in fast fashion, you have to pivot.
Right.
If you can't win on the price tag, you have to win on the literal, physical feel of the product.
Differentiation became a matter of corporate survival. Mills needed a quality that could be instantly felt by the consumer standing in a retail store, not just a metric measured by a factory manager on a spreadsheet.
The consumer has to touch it and go, oh, this is worth more.
Exactly. And because of that urgent need, Biancalani's role in the industry completely transformed.
How so?
They stopped being viewed merely as vendors who sold hardware.
Ah, they evolved.
Right. They evolved from a machine supplier into a strategic partner.
Mills weren't just buying steel machines anymore.
No, they were buying holistic solutions for survival. Whether a company was producing high-end apparel, heavy home textiles, or even specialized technical fabrics for industrial applications, they went to Biancalani to figure out how to mathematically elevate their fabrics above the cheap global competition.
The finish literally became the manufacturer's competitive shield.
Exactly. If your fabric feels undeniably better, if it drapes more elegantly and survives the washing machine better than the cheaper alternative, the consumer will choose yours.
Or the high-end fashion label will source from you instead.
Right. You have effectively protected your value from the race to the bottom.
That is such a fascinating pivot. But as we bring this deep dive into the present day, the sources highlight that the modern textile industry is facing an entirely new crisis.
And it's a big one.
Yeah, and this one isn't just about economic competition or outmaneuvering an overseas factory. It's a non-negotiable systemic challenge.
The environmental impact.
Exactly. We're talking about environmental sustainability, specifically the massive water, energy, and chemical consumption historically required to make the clothes we wear.
The textile industry is notorious for its environmental footprint. It's often cited as the second most polluting industry in the world.
Which is terrifying.
It is. And finishing, by its very nature, is historically heavily resource dependent.
Right.
Traditional finishing relies on massive heated water baths. I mean, you have to fill enormous vats with thousands of gallons of water.
Just to soften the clothes.
Yeah, and you use tremendous amounts of energy to heat that water to near boiling, and then you just dump synthetic chemical softening agents into the bath to treat the fabric.
That sounds wildly unsustainable. So, how does an industry built on such resource-heavy, chemically intensive processes survive in an era of strict environmental regulation and global ecological crisis?
By returning to that original philosophy we talked about, taking responsibility for the transformation.
Oh, Biancalani's quote.
Exactly. Modern finishing technologies can no longer just be about making a fabric softer or outcompeting a rival on quality. The engineering must actually reduce water, energy, and chemical usage at the source.
So it's not an add-on, it's foundational.
Right, and this is where the physics of air-based technology proves vital all over again.
Wait, the air machines?
Yeah. When you use aerodynamics and kinetic energy to mechanically soften a fiber, you drastically reduce the need to soak that fiber in a heated chemical bath.
Oh, I see. Because the air is doing the physical work of relaxing the yarn rather than a chemical agent doing it in hot water.
Precisely. If you can replace a 5,000-gallon heated water bath with an aerodynamic tumbling chamber, the energy savings are absolutely staggering.
You are no longer burning fossil fuels just to heat water.
Right, and you are no longer generating toxic chemical effluent that needs to be treated before it enters the local watershed.
Wow. The sources make a point that really frames this shift perfectly, I think. They emphasize that modern finishing tech that slashes these environmental impacts isn't just good business or, a clever PR strategy.
No, not at all.
It is an absolute imperative.
It is. If you synthesize Biancalani's core belief from 1957 that true innovation is about taking responsibility for the transformation of the fabric, it remains perfectly relevant today.
It really held up.
The scope of that responsibility has simply expanded.
Right. It is no longer just a responsibility to the consumer's sensory experience.
Exactly. It's a responsibility to the planetary ecosystem. Engineering a better finish today means engineering a process that requires a fraction of the carbon footprint it used to.
We have tracked a massive hidden journey today.
Right.
We started in a tiny workshop in Prato, fighting against an industry totally obsessed with sheer output.
And brute force.
Right. And then we watched the invention of aerodynamic, air-based technologies that brought, almost an artistic touch to heavy industry.
It really was a revolution.
And we saw how those machines became a strategic shield for economic survival during globalization. And now we see how they are at the forefront of the fight for environmental sustainability.
Well, it's incredible.
It really shows how profoundly a single shift in perspective can ripple out across decades.
Yeah, viewing something as a fundamental value creator rather than just a final logistical step completely reshaped a global supply chain.
So think back to that fabric you were touching at the beginning of our deep dive. The next time you put on a piece of clothing, maybe it's your favorite worn-in t-shirt or a perfectly draped sweater and it feels incredibly soft, breathing naturally as you move, I want you to remember something.
You aren't just experiencing a raw material.
Exactly. You are experiencing a highly engineered finish. You are feeling the physical result of decades of aerodynamic innovation, tracing all the way back to a workshop in Italy that decided the final invisible touch is actually the most important part of the journey.
And the sources leave us with a really fascinating paradox to consider.
Oh, what's that?
Well, they make it abundantly clear that finishing is the ultimate value creator. It defines a fabric's final feel, its premium quality, its durability, and even its environmental footprint.
Right, it's everything.
So, if the finishing process is the true differentiator of a textile, does this mean our modern obsession with labeling clothes simply by their raw ingredients, like a tag proudly declaring 100% cotton or 100% silk, is actually giving us the least important piece of information about what we are really buying?
Oh, wow. That really does change how you look at the tag on the back of your shirt.
It does, doesn't it?
Thank you so much for joining us on this deep dive into the hidden mechanics of the textiles we wear every single day. Keep asking